CNC milling machine tool system. The courseware shows indexable milling cutters, solid carbide milling cutters, and high-speed steel drill bits. These milling cutters can all be used for milling operations, but they differ in structure. The insert milling cutter uses a mechanical clamping method to secure the insert on the tool body, making it convenient to replace the insert. In contrast, the solid milling cutter has a body and cutting teeth made as one piece, providing a relatively stable structure. End mills are disc-shaped milling cutters, primarily designed for machining large flat surfaces on parts. These cutters can only use the cutting edge on their top surface, making them particularly suitable for machining large flat areas. Round-nose milling cutters, on the other hand, are especially suited for rough machining of mold blanks, as well as for precision and side finishing of flat surfaces, particularly in materials with high hardness. In addition to milling cutters mentioned above, boring tools are also commonly used. In the past, when boring on CNC milling machines, great care has to be taken to avoid coolant splashing onto the electronic components of the boring hand's digital display device. Today, newly designed boring tools have better solutions to this problem. Thread milling cutters are specialized cutting tools used for machining threads. They typically consist of several cutting teeth with fine cutting grooves. When the thread milling cutters starts rotating, the teeth continuously cut the workpiece surface, eventually forming the thread shape. Compared to traditional thread machining method, threading milling has significant advantages in machining accuracy and efficiency, and it is not restricted by thread structure or thread direction during processing. A complete tool holder consists of a pull stud, a milling cutter, a collet, and the tool holder body. The structure of a drill trunk includes a pull stud, tool holder body, chuck, and drill bit. When machining, the selection of milling cutters comes into play, and at this point, it is essential to understand the parameters of the milling cutters. The main parameter on a milling cutter includes the shank diameter, cutting edge diameter, cutting edge length, and overall tool length. For example, the milling cutter just seen can be interpreted as a tool with a 12 mm shank diameter, 12 mm cutting edge diameter, 26 mm cutting edge length, and a total tool length of 18.3 mm. The selection and clamping of milling cutters must meet the following 4 principles. Principle 1. Under the premise of meeting the machining depth, the tool should extend from the milling chuck, correct, as short as possible. Principle 2. Under the premise of meeting the minimal curvature radius of the profile concave arc, the tool diameter should be as large as possible. Principle 3. Under the same machining conditions, choose tools with fair teeth and larger helix angles for roughing. Principle 4. Under the same machining conditions, choose tools with more teeth and smaller helix angles for finishing. Common clamping devices for milling cutters include the tool clamping wrench and the tool holder, locking device. Next, watch a demonstration video on clamping and unclamping tools. This concludes the introduction to the CNC milling machine tool system.